Before we start the video, let me give you a brief introduction about myself. I'm Chandresh Mahajan, who is founder and chief educator at Exergic, which is India's most trusted and comprehensive institute for online gate preparation. I got an All India rank 37 from Gate Mechanical Engineering, and I am an ex Indian Oil officer, having 6+ years of teaching experience as of now. To know more about our GATE courses, you can contact us on these details. Also, you can download Exergic GATE preparation app from Google Play Store. The link is available in the description of video. Let us have a look at this question. It says that a 4-meter bar of negligible weight, so its weight is not to be considered, rests in a horizontal position. Its position is horizontal on the smooth planes. Okay, one more keyword. So the first statement itself has many keywords. There is a bar of length 4 meters. If you look at the diagram, you will be able to locate bar AB, this bar AB, which is having a length of 4 meters. It has negligible weight, so its weight is not to be considered, and it is resting, means it is in static equilibrium in the horizontal position. So this is forming a horizontal line. It is horizontal on the smooth planes. It is resting on this and this plane, and these planes are smooth, means friction is not to be considered. The question further says that compute x. Where is x in the diagram? This is the x. This length is x. So compute the distance x at which T is equal to 10 kilonewton. A force of T having magnitude 10 kilonewton should be placed from point B to keep the bar horizontal. So in this question, initially the bar is at horizontal position, but it has to be acted upon by a force T such that it stays in the horizontal position. The magnitude of T is 10 kilonewton. So basically, under the action of all these forces, whatever forces directly or indirectly the reactions are acting, under the action of all these forces, this particular bar not only should be in static equilibrium, but it also should be in horizontal position. Now the question will look very easy and straightforward to you, but still there is a certain concept, very interesting concept, that I want to discuss with the help of this question. So let us jump right into the question and then I will explain that. Step number 1 obviously would be to locate all the direct and indirect forces, for which we need to draw the free body diagram. P is a direct force, T is a direct force, P is known, T is also known, 10 kilonewton. The reactions from A and B, those are not known. Friction is not to be considered since planes are smooth. And I have already told you that whenever you have interaction between any surface and other body, the direction of reaction will be along the common normal. So for such a case, when you have a surface and any body is in contact with this surface of whatever shape, what you need to do is, at that point you need to firstly draw the common tangent. Now since the surface that we are dealing with itself is straight, so this is going to be the common tangent, this is going to be the common tangent, and then you need to draw a line perpendicular to this, which is going to be common normal, perpendicular common normal. Okay, so in this case, in the given question, at this point, this is the common tangent, this is the common normal. Okay, similarly here, this is the common tangent, this is the common normal. The concept of common tangent and common normal we will further discuss in theory of machines unit of gears. All right, now in this case, at this point, common normal or reaction will be along this direction RA, and here it is going to be in this direction perpendicular to the surface RB. Obviously you can calculate the angles because this and this are perpendicular. If this arm is making 30 degree, this arm is making 30 degree with the horizontal, the perpendicular arm will make 30 degree with the vertical. I have already told you this concept, right? So RA's inclination is also known 30 degree with the vertical or 60 degree with the horizontal, right? Similarly, in this case here, if this is making 45 degree with the horizontal, the perpendicular line will make 45 degree with the vertical or 45 degree with the horizontal. I have already explained this trick to you a number of times before, so I am not repeating it again for this question. So for both RA and RB, we know their orientations as well, right or not? Now, what would be your approach? Your approach would be, as I have already told you, apply the summation of force in vertical direction because two forces are already in the vertical direction. Then maybe you will take moment about some point, and maybe you will again require to take the summation of horizontal forces, right? But this problem here, we are going to solve by the graphical method. What is the graphical method? What is the graphical method? The method of force triangle or force polygon. In this case, what do you think? What will be formed? Will a triangle be formed or a polygon will be formed? It's a very good question. In this case, you will say that, sir, there are 1, 2, 3, and 4 forces acting. And sir, as we know, you have taught us that if we have 3 coplanar concurrent forces in static equilibrium, they are going to form a triangle, right or not? And similarly, if we have more than 3 forces, if we have 4 forces which are coplanar, and in that case if we have static equilibrium, they have to form a closed polygon, which we were referring as force polygon. Sir, in this case there are 1, 2, 3, and 4 forces acting, so it must form a polygon having 4 different sides, right or not? No, it will form a polygon, but that polygon will be a triangle itself. I told you that triangle is also a polygon with 3 different sides. A square is a polygon with 4 different sides. A pentagon is a polygon with 5 different sides. So polygon is a general term, right? But whether that polygon is going to have 3 sides or 4 sides, that is something that question can ask you. And if you look at this question, you will say that, sir, 1, 2, 3, 4 forces are present, so there will be a polygon with 4 sides, which is incorrect. That is not correct. And that is why this question can not only be asked like this as a proper numerical question, but gate can also give you such situations and can ask you that in the force polygon, tell that how many number of sides will be present. It's a very feasible question. It can be asked to you in gate. In that case, what you will think? You will think that since 4 sides are present, so it will be a polygon with 4 sides, and that is going to be incorrect answer. Let me tell you why. Look, all these forces have to form a closed polygon, right? Let us try to form the polygon using these 4 forces. And out of those 4 forces, 2 of them are vertical, right? You have a force in this direction. It is clearly greater than T. T is 10 kilonewton, P is 20 kilonewton. So P will be 2 times in length as compared to T. Roughly we can draw it, right? Correct? RA is going to be in this direction. Maybe you will join it like this, because if you put it like this, it is not going to close like this, not going to close like this, it is not going to close. But if you form it like this, it is closing up. Similarly, RB, if you put like this, it is closing up. And then you will say that, sir, this is our force polygon. Tell me, is it the right polygon? Is it a correct polygon to make? You will say that, yes, sir, definitely. We have 4 different sides. It has 4 sides present. It is getting closed, and it is a force polygon. You are incorrect. The direction of arrow I also told you which one is to be considered. All those arrows should be cyclic. They should form a cycle. We are not finding out the resultant. We are drawing the force polygon for a system at static equilibrium, which should be closed in the same loop, in the same cycle. So this is moving like this force is moving like this force is moving like this, but this force is moving against the cycle. Ideally this force should be in the upward direction, then it will form a loop, a cycle. But here, this force is moving in the downward direction. It is not forming the loop. It is not forming the cycle. It is a very small thing to notice. Yes, if question was asking you the resultant of this and this force, then it was correct, because I have already taught you that for resultant, the fourth side should oppose the loop, should oppose the cycle. But when you are trying to plot the equilibrium diagram, the polygon for static equilibrium, all the four sides should be in the same loop along the same cycle. That is why this force here is incorrect. It is not falling in the right direction. So this is not the correct polygon, force polygon for the given case. Interesting, right? Then what else is possible? Is it possible to form a four-sided polygon of this system other than this? If you try to make a polygon with four sides, you cannot do it. It will not be possible to make, because look, these two are along the same direction. This is the main issue here. Both of them are in the same direction. You have to draw them like this and other like this. Even if you change their orientation, maybe P you put here and T you will be putting here, that will also not change the things. This is going to be RA, this is going to be RB. Again, look, cycle in the same loop, in the same loop, in the same loop, again it is opposing, right? So a four-sided polygon you cannot make for such body. Then how is it possible that body in static equilibrium, four forces are acting, but still you are not able to make a polygon with four sides? Because it is not a rule. This is something which, in theory, if I told you, you would not be able to understand that how is it possible that if we have four forces, then we cannot make a polygon with four sides. That is why I left this concept for the question to be explained. Now, what is the other way in which we can close it? At least try to close the loop. At least try to close the polygon. Maybe if not by four sides, maybe with three sides. Can we do it with three sides? Yes. These two forces are totally vertical, and this is something that you must write in your notes right now. Whenever you are trying to form a closed polygon of different forces, and there are two forces along the same direction, for example P and T here are in the same vertical direction, in that case there are full possibility that the polygon that you will form may have less number of sides than the number of forces present. Here four forces are present, but polygon will be having three sides. How? Because force P and force T are in the same direction. It is a possibility that both of them are forming the same side of the polygon. This is RA, this is RB. What do you think? Is it closed? Yes. Is it a polygon? Yes. Are the forces in the same loop, in the same cycle? Yes. RA is in this direction, P here, T here, RB here. Perfectly, they are in the same loop, in the same cycle. And even this one also you can consider to be a polygon with four sides. How? Because P and T, you can consider the two different sides of the polygon with 180-degree angle between them. If I have 1, 2, 3 and 4, these four sides, A, B, C and D side, if the angle between C and D side become 180-degree, then this is going to be a straight line. C and D will form a straight line, right or not? So in a way you can also say, a different way to look at it is that it is still a polygon with four sides, right? But P and T are having, two sides are having an angle of 180-degree between them. But this is something which is satisfying all the conditions of force polygon that we discussed, that it should be closed, all the forces should be present into that, and the arrangement of forces should be in such a way that they form the loop, form the cycle in the same direction, in the same sense, all clockwise or all trying to be anti-clockwise. So all these three conditions are getting satisfied. So leaving this question aside, forget about this question. Even if gave you just this diagram and asked you the force polygon, it gave you 4 options A, B, C, D, many of the students will get confused, will not be able to take any of them, because they will think that this is not possible because only 3 sides are present, and that one also, the earlier polygon that I showed you, was also violating the loop rule. So they will get confused, but you don't have to be confused. It is full possibility that number of forces can be more than the number of visible sides of the polygon, like in this case. Important one, you must write it down in your notes. Now let me draw this force polygon a little more clearly, and then we will be solving this question. So this is how the force polygon is going to look. P, which is having 20 kilonewton, is visibly more in length than T, which is having 10 kilonewton length. Coming to the orientation, the angles, I have already told you that RA will be having 30° with the vertical, right? Because this perpendicular to RA is having 30° with the horizontal. So RA will be having 30° angle with the vertical. Now, if that angle is shown here or here, it does not matter. Both the angles are with the vertical, or from this diagram's perspective, they are alternate interior angle, basic geometry, right? Similarly, RB is making 45° angle with the horizontal as well as with the vertical. From here, we had already concluded that. So here also 45 angle is being made from the vertical like this. So this angle here, this angle will be 45°. This angle will be 30°, right? This is the only angle left in this polygon or in this triangle, which we can easily calculate, because in this straight line 30 plus 45 plus this unknown angle should be equal to 180°. So if you do that, this unknown angle will come out to be 105 degrees. This is 45 degrees, right? 105 plus 30 here plus 45 here will be equal to 180 degrees. Basic school level geometry. This is the force polygon that is known to us. And now we are going to apply the concept of force polygon, or you can say the concept of Lami's theorem, what we already covered. It is very interesting to see that although Lami's theorem was applicable for 3 concurrent coplanar forces, but in this case also, when you have 4 forces, you can apply it. That is why I chose this question, to tell you such exceptions, so that if any theoretical question is also asked from the same question about Lami's theorem, that when it is going to be applicable, if option says that it is only applicable for 3 concurrent coplanar forces, it is incorrect. Because in this case also, although number of forces are more than 3, they are 4 forces, but still geometrically it is a triangle, and you can apply Lami's theorem here also to get the answer, because the third side, this side, is effectively a single vector p plus t, right or not? So if you apply that, in order to find out this distance x, what should you do? What exactly should you find out in this particular question to know the length x? Let us discuss that. Let us now start discussing the question. Till this point of time, we were not discussing the question. If I just wanted to solve the question, we can solve it without the force polygon as well, by just considering the static equilibrium conditions, right? So now let's discuss the question, how we can solve this question using the force polygon. X is to be calculated. This distance has to be calculated for static equilibrium. The best way to do that is by taking moment about any particular point and then equating all the moments to 0, since it is in static equilibrium. I have already told you in previous so many examples that moment is the only and only static equilibrium condition which can be used in different varieties depending upon the problem depending upon the condition. In this problem, you can clearly see that a distance is to be calculated, and whenever you have any static equilibrium condition where some distance is to be calculated, the preferred condition should be summation of moment, because this condition not only consider the forces but also their distances from any particular reference. So we will definitely apply the summation of moment as 0 about maybe point A, about point B. Let us decide that later on. Whatever you decide, if you take it about A, then also x is going to come, 4 minus x will be coming, this length will be 4 minus x, right? So the moment of t about A will include a x term, or if you take it about point B, then also x term will be coming, right? But in order to do that, in order to apply that, you need to have either RA or RB. You cannot apply this condition without knowing either RA or RB, because if you take the moment about A, then RA will not be needed but RB will be needed, and if you take the moment about B, RB will not be needed but RA will be needed. So you need to find out at least one of them so that you can proceed ahead and find the value of x, and that unknown you can calculate from the force polygon. So let us do that. Let us apply the Lami's theorem for this force polygon. So according to that, this side, which is P plus T in magnitude, P plus T divided by sine of opposite angle, which is 105, this should be equal to RA. Let us try to find out RA divided by sine of opposite angle, which is 45, sine of 45, right or not? I'm sure you can recall this from our previous discussion. And if you solve it, you will get the value of RA as 21.9615 Newton. And since we have calculated the value of RA, if we take the moment about point B, RB will be vanished. So you don't need to find out the value of RB. Let us take the moment about point B. If you do that, you need to equate all the clockwise moments with all the counterclockwise moments. T is definitely going to move counterclockwise. P is also counterclockwise about B. So T multiplied by X, counterclockwise moment, plus P multiplied by this distance, which is 3, because 4 is AB, AP, this distance is 1. So BP is going to be 3 meter. So 3P. All right, let me write it here only. Tx plus 3P. These two are moving counterclockwise. Now coming to RA. I think from the previous many examples, you should not take more than 5 to 10 seconds to find out the moment of RA about B. Recall previous examples. What I taught you? I told you that whenever you have such a force where perpendicular distance is not known, in the case of RA, you don't know the perpendicular distance directly. You need to extend it, you need to do some construction in order to find out the perpendicular distance. In that case, what I have taught you? I have taught you to take the moment, to take the component of that force, one here, other component here, right? Two components will be there, RA cos theta, RA sin theta. Then it will be easier for you. This component you can clearly see has a perpendicular distance of 4, right or not? This component is passing through the B, it will be 0, it will become 0. No need to find out its moment, right? So I'm not explaining this concept here. I have already done this in the previous examples. So using that knowledge, let me break down RA into two components. This is moving in this direction, right? This angle is 30 here. So this is RA cos 30, RA cos 30. This is RA sin 30, which is passing, which is very much passing through the same point B. So moment of RA sin 30 will be 0. Only RA cos 30 is moving in the clockwise sense. P and T are moving in the counterclockwise sense. So it will be resisted Let me only show RA cos 30. So Tx plus 3p, the counterclockwise movement, will be resisted by the only clockwise movement RA cos 30 multiplied by the perpendicular distance of 4. And now you need to solve it. T is given as 10 kilonewton. X is unknown. P is given as 20, so this will become 60. RA you have calculated 4 multiplied by 21.9615. Cos 30 is root 3 divided by 2. And let us solve it to get the value of X as 1.608 meters. This is the required answer for this question. If some of you are confused that, sir, the values were in kilonewton, why did you not convert them into Newton? Then it's a very basic doubt, because all these forces, whatever their units are, they will be cancelled, right? So all of them should be having same units. It will not matter whether they are in Newton, kilonewton, or whatever unit of force they are having.